Today we're talking reference angles. Let theta be an angle in standard position. Its reference angle which we'll call theta prime, is the acute angle formed by the terminal side of theta and the horizontal axis. Always the horizontal axis. Reference angles are always positive. So to find reference angles, the first thing I would do is sketch theta. What that does is help you figure out what you need to do to find the reference angle. Let's do a couple of sketches. Let's first sketch if theta is in quadrant 1. So if theta is in quadrant 1, then that means, there's a theta right there in quadrant 1. The reference angle is the acute angle formed by the terminal side and the horizontal axis. So in this case, theta is equal to theta prime. So there's no work that needs to be done. So for example, if we have theta being 15 degrees, its reference angle is also 15 degrees. If we're in quadrant 2, let's go ahead and draw theta as an angle in quadrant 2. Theta prime, its reference angle, is formed by the terminal side and the horizontal axis. So right now, theta prime would be right there. So as I look at this picture, I can see that theta plus theta prime should be equal to 180. They form a straight line. So I would say that theta plus theta prime should be equal to 180 degrees. Or if we're in radian, theta plus theta prime is equal to pi. Now you can use that idea to actually solve for theta prime, the reference angle. It would just be 180 minus the angle itself. Or if we're in radian, pi minus the angle. And all I did was I took the idea over here and isolated the reference angle. Let's see what happens if we're in quadrant 3. So I would draw an angle here. That's my theta in quadrant 3. My reference angle is formed by the terminal side and the horizontal axis. So that one right there would be theta prime, the reference angle. So what I can see here, that theta minus the reference angle, I can just see that from the picture, that theta minus theta prime, the reference angle, should be equal to 180. Taking the angle and subtracting away the reference angle would get me back to 180. Or if we're in radian, it would get me back to pi. Again, I can use this idea to solve for the reference angle. Just using these formulas here to solve for the reference angle, I know that the reference angle would be theta minus 180 or theta minus pi. If you're in quadrant 4, there's theta in quadrant 4. The reference angle, theta prime, again, is the angle formed by the terminal side and the horizontal axis. So it would be right there. So just looking at the picture, I can see that theta plus its reference angle should be equal to 360. Or if we're in radian, it would be equal to 2 pi. So again, I can use those formulas to just to isolate the reference angle. I can use this idea to find that the reference angle is 360 minus theta or 2 pi minus theta, depending on if you're in degrees or radian. So let's see a couple of examples. So if I said theta is 300, let's go find its reference angle. The first thing you should do is sketch 300. I know that 300 is in quadrant 4. So that's theta being equal to 300. So I know that the reference angle is this one. So now I'm thinking theta plus theta prime, the reference angle should be 360. And so theta is 300, so theta prime would have to be 60. It's a 60 right there. You can also use the formula that we had on that last page, that theta prime is equal to 360 minus theta. 360 minus 300, which is 60. Let's do another one. Let's say that theta is negative 135. I know that's negative 90, negative 180, so negative 135 would be around there. The reference angle would be this one here. So now, since we're going in the negative direction, now that I've sketched it out, I can tell that these two angles should add up to be a straight line. Technically negative 180, but we're just thinking about the reference angle in a positive light. So negative 135, how much further would I have to go to get to negative 180? Well, I'd have to go 45 degrees more. You can think about this in another way. So negative 135 is coterminal with 225. And I know that because if I add 360, negative 135 is the same as 225. 225 is right here. That reference angle, theta prime, would be that piece. So now since I've sketched it out, I can see that theta minus theta prime, the reference angle, should be equal to 180. Theta minus the reference angle should be equal to 180. So 225 minus the reference angle is 180. You can solve to find that the reference angle, again, should be 45. Now let's see an example in radian. Let's say theta is 13 pi over 18. The first thing I would do is sketch it out, labeling my quadrantals as 18 pi over 18, 9 pi over 18, and that should be enough there. 13 pi over 18 would be in quadrant 2. The reference angle is formed by the terminal side and the horizontal axis. So that's the reference angle there. I can see that theta plus theta prime should be equal to pi, or 18 over 18 pi. So theta plus theta prime should be equal to 18 over 18 pi. Now I know that theta is 13 pi over 18, so I'm just asking myself how much further I need to go to get to 18 over 18. And the answer would be 5 pi over 18 more.